Hi, good afternoon, everybody. Hope you all enjoyed your lunch. My name is Steven, and my group members are Nick, Aldo, Edwin, and Lorenzo. Today, we will be presenting to you the harness tool automation. And I'll be briefly going over the introduction. I'm pretty sure everyone's looked up at the night sky before and wondered what those lights are shining back at you. Is it a star, a satellite, or maybe even a UFO? But then you come to realize to yourself that you might be staying up too late. And the reality of it is that there are many things up in space, including over 4,000 satellites. However, only 30% of those satellites are in operations today. And for those satellites, they are used for many different tasks, such as communication, research, and even taking photographs. And for these satellites to work, they have to communicate between its different components and systems. And for that, they use hundreds of different wires bundled into many different harnesses. And it's similar to the nervous systems in our body. Back. And Boeing brought this project to us to help solve the problem of spacecraft harness being time-consuming, labor-intensive, and also prone to technician manufacturer defects. However, this doesn't only apply to the aerospace industry. This also applies to the automotive industry, consumer electronics, biomedical, and many different other industries. And not only this, but the technicians that are working on these harnesses, they work with hand tools all day. So they are prone to suffering health symptoms such as carpal tunnel syndrome. And our objective for this project is to design, analyze, and build a prototype of an automated wire stripping, tinning, and crimping machine. And all of our requirements have been met, so the final prototype is small and lightweight enough to be easily transportable. And each of the processes do meet the NASA specifications that have been provided to us, and also meets the environmental requirement of being clean room compliant. Thanks.
Oh, that's a reduction.
That's right. And so at the beginning of the project, we have been provided with a $1,300 budget. And by the end of the project, we spent 62% of it, leaving us with $491 remaining. And now I'd like to invite Nick to go over the wire transition.
Thank you, Steve. So I'll be going over the mechanical overview. For this, we have 5 different components that make up the entire system. In the upper right hand, we can see that's the wire transition. That's going to be what's going to move the wire from the input, where the technician puts it in, all the way through down below where the wire stripping is, goes through that process, moves it to the camera inspection, as we can see here. And then depending on if it's a wire crimping or a tinning, it will move it to that, and then it'll also return it back to the start, so it can be so the process can be complete. So to move this wire, this is how the wire is inserted here by the technician, and then it rotates around to the stripping position where it then lowers down to the designated height that needs to be stripped, and allows the stripping position, or the stripper, to actually remove the insulation. Once it's finished the stripping position and the insulation is removed, it goes to the camera inspection, where then it is checked for nicks, defects. If it passes, then it goes on to the tinning or crimping station, which is the next one over. But if it fails, it automatically goes to the wire release position where then the technician can check it out and see why there was an issue. So there's a lot of components that went into this and a lot of time that went into actually creating this system. It's actually ran off 2 stepper motors. One that does the lift up and down, and one does the rotation through a power transfer where using gears to rotate the chain all the way around. On the outsides, we have 2 support shafts to help aid in the guidance and repeatability of the actual system and to eliminate twist. And then on the round circular gears on the sides are actually chain supports. It actually helps support the chain from too much deflection. And then the stripping support is what will absorb and take the actual force of removing the insulation. It's rated up to 7 pounds, so it can do a little bit larger wire if needed. But for this specific one, it just has to be able to handle a 3-pound at most pull force. Up next, Stephen will be going over the wire stripping.
Thank you, Nick. So for the wire stripper, there is a CAD design on the top right-hand corner and the actual wire stripper mechanism on the lower right-hand. And this is a top view of the wire stripper, so the wire stripper mechanism is automated. And it's automated using a servo, so the servo controls the opening and closing of the wire cutters. And these wire cutters, the dies themselves, they're commercially available, so they're easily replaceable, and they are interchangeable for different wire gauge sizes. And for the wire stripper mechanism, we did also have to implement a wire guide to line up the 30 gauge wire, because without the guide, the wire would usually kind of flop to different size and it wouldn't give a clean strip. And the wire insulation removal process, at first it will be fed down from the wire transitioning system as previously stated. And once it's fed down to a specific depth, the wire stripper will close and it will cut into the insulation. Once it's fully closed, the wire transitioning will move back up, removing the insulation nub below it, and it will fall into the waste containment. And then once that process is done, it will move on to the camera inspection, which I'll invite all of us to present.
Thank you, Stephen. So once the insulation is removed, the conductors need to pass a visual inspection. One way to automate that is by using a PI camera. We chose a PI camera because it was compatible with our microprocessor. It was right within our budget, and it met our operational requirements. This is the wire inspection hardware. We have a camera and a servo. The camera will rotate around the wire 180 degrees. At 0 degrees, it'll take a snapshot. Once it takes a snapshot, it'll run its image processing to detect if there's copper. Then it'll go around the wire 180 degrees and repeat the process. We're able to find the color of the threshold of copper by using MATLAB. After we use MATLAB, we use Python 3 and OpenCV to automate the image processing. If there is no copper detected, meaning it's a good strip, then we'll proceed to the tinning and crimping station. I'll have Edwin discuss the tinning and crimping.
Thank you, Olo. So, as we stated earlier, the next process after the wire has been successfully stripped and inspected, since it is a modular system, there's 1 or 2 processes that can take place. The first one we're going to be talking about is the crimping process. Crimping is the process in which a contact is applied to the end of a stripped wire. As you can see here on your bottom right corner is an example of a stripped wire. The next picture over shows a crimped wire. And then once the wires are crimped, and the application that we're designing this for is to be used in wire harnesses that are using satellites. So as you can imagine, there's plenty of wires that are involved. So being able to put these wires into connectors facilitates the process of connecting these satellites together. So what we did was we took a commercially available crimper And the objective here was to replicate the motion that a technician uses, as well as the force required to complete the crimping process. So for this method, we had to go with the high torque servo motor in order to be able to use the appropriate forces. And in order to avoid any kind of deflection, we had to use a aluminum servo arm. We had made a plastic one, but the plastic one was giving too much deflection. So this was pretty readily available, and we went with this aluminum servo arm. So as long with the forces that the technicians have to apply, as you can see, these contacts aren't very big to begin with, so it does cause a strain on the eye, as well as making it very hard for the technicians to be able to handle on a daily basis. So this method would automate that process and eliminate some technician error. The next step that can happen, if it's not going to be crimped, it'll be tinned. And tinning is a process in which there's solder applied to the end of the stripped wire. The reason you want to do this is because once these wires are stripped, they have to be connected either onto another wire or onto a contact point, as we do on the satellites. Right now, the technicians usually do it using a soldering iron, or they use pots where they can dip the wire into. What happens here is there's some unpleasant fumes that are given off. In order to mitigate this, we have designed the tinning station, which incorporates a solder pot as well as a heating element. So the heating element, as you can see down here, pointed with the purple arrow, it goes into the solder pot. It will heat up the pot, and then the wire transitioner will go to the station, dip the wire in, and pull it out. We also have sensors which tell us what the temperature of the pot is, as well as the displacement of the solder, which lets you know if you need to refill the solder pot. So here's an example with wire before it's tinned and after it's tinned. As you can see, once it's tinned, the strands are a lot closer together, neater, and it's a lot easier for the technicians to be able to join this onto a contact point or another wire. And up next will be Lorenzo with the electrical.
Thank you, Edwin. Okay, my name is Lorenzo, and we go over the electrical hardware. Okay, so we have three main things we're going to go over. We have a pretty complex system, so just to simplify things, it's broken down into three categories. The first category will be the motors. The motors are for the servos, and it's designed to give the machine the ability to crimp, strip, and remove the wire, remove the encasing off the wire. And then we have a camera that will inspect the actual wire to make sure it's not nicked. And then we have sensors and a display that will tell the user the temperature of the actual solder pot and how much solder is left in the system. Okay, so here we have the electrical design. On the very top, we have a camera, we have a thermocouple, we have a time-of-flight sensor, and we have LCD. The camera is for inspection. The thermocouple is to measure the temperature of the pot itself to maintain a constant temperature. We have a time-of-flight sensor, and that sensor is the device that will pick up the displacement of the pot to tell you how much solder is in the system. And on the bottom, we have our Raspberry Pi, which is doing the image processing. And then we have two Arduinos. And one Arduino will do the heavy lifting of the entire machine. Then we have another Arduino that's dedicated to the display and to the solder pot. And on the very bottom, right here, we have our DC power supply. And that is going to power the entire system. And then we have our group of motors, which are 3 servos. We have 1 servo to move the camera around the wire to get 180 degrees for inspection. And then we have another servo that actually closes the crimper. And then we have 1 more servo to remove the wire after it's been stripped. And we also have 2 steppers that will power the entire system. Okay, so conclusion, we stayed in the budget, we met our requirements, we were able to automate the entire process. Hopefully this will reduce the technician load They work with their hands a lot. We don't want them developing carpal tunnel. Maybe it'll ease their job a little bit. And we want to minimize human error. We know satellites are very, very important. Electricity is very important in general. So if those satellites go out, we could be watching the Dodger game. It'll be the World Series. It'll be, top of the ninth, Kershaw's pitching. And then the TV goes out and everybody's going to be angry. So we want to make sure no one misses those moments, but without any faulty wire connections. Okay, thank you guys.
Hello everyone, so questions from the audience? Yes.
So, copper detection, right? What about if the copper is cut? Then
Well, because the conductor we're using is copper that's silver plated. So if there is any nick or scrape, the color copper will be exposed. And so that's what we're looking at.
Other questions? Yes.
Yeah. I know you guys made a lot of emphasis on technician safety and whatnot. If you project that to another use, do you think, how does the speed of this compare to the speed of the actual manufacturer, handmade manufacturer? Is this automation increase the speed of the service that the equipment is providing tenfold, twice as fast, slower? Do you guys have any data on that?
Currently, right now, it's not, because there's a lot of delays just to get the processing down. So right now, it's actually slower than what the technician would, how the technicians would do it. But once it's optimized, it would be faster because then the technician wouldn't have to go switch tools or have to go to a different area. Go to like a different area. Because say, for example, for the wire stripping and soldering, they may do it in different areas because like the fumes with the soldering, or when they have to thin the wires. So I'll say like in the future, once it's optimized, it would be faster. But
I could do a follow up on that. How, in detail, how would you optimize that? How would you further optimize that? I know time is always a factor, so how would you proceed from here?
for the optimizations, so it would kind of go through the coding, and we would get rid of any delays and kind of see where the bottlenecks are. We do have a lot of ideas where the bottlenecks are, so just optimizing that area.
Or other questions? Yes.
You do some test run and how many times you tried it and the failure rate that you have encountered or it's all successful?
Yeah, so we did do test runs. So at first we test run individually since it's all modularized. So wire stripper, tinning, and crimping have been test run individually. So they work really well, like for the wire stripper, it doesn't nick any wires. However, when we implement it all together as one whole system, it doesn't run perfectly because there are minor issues kind of getting the timing right. Getting the timing right and having the wire kind of go through the process correctly.
So the follow-up would be, is that the area that you will focus on to improve and look into the improvements?
Yeah, so for the next step, like for improvements, what we would kind of do is add a few more feedback sensors to know where the position of the wire is each time. And by knowing that, because right now it's on an open loop system, so by making it a closed loop system, it should be more accurate. So it knows where the wire is and its position at each station instead of having to kind of estimate it right now.
Okay, so now we are out of time for the questions. Let's give the